my name is Milos, and I'm a freelance IT consultant. I've been working past 8 years, particularly on introducing event-driven architecture in organizations, and that leads us to this session today, which is somewhat inspirational, where I would like to talk about why event-driven architecture can aid organizations become agile on architecture level. So currently I'm sitting with a client called FK Distribution. Started as an architect, but they hijacked me as a CTO until they find the full-time CTO. I'm a consultant, so it's not a durable solution for them, but I'm sitting now in that position. So used to be fun with the architecture, but now I'm going to be running through PowerPoint slides. So let's try, see how fun that can get. I'm going to kickstart the session very simply by putting up somewhat bold statement, which is saying that by applying the event-driven architecture patterns and practices, we can bridge sourcing silos through event-first thinking. We can also improve cohesion through inversion of responsibility, as well as embrace changes through evolutionary architecture, and hence become agile on architecture level. So what's important to state here, this is not hypothesis, this is thesis, and throughout this presentation I will try to support it. And that's where you come into the picture. You will try to make it difficult for me. So let's have also a dialogue as good as possible, but also keep in mind that we have only 3 quarters for this, and there is some material to go through. And first thing first, before we jump into the core statements, we just align a little bit our understanding of event-driven architecture. Nothing too deep. This is not about what, it's not about how, it's more about why. So, but in order to explain why, so let's touch a little bit on what event-driven architecture is. In simple words, you could say that this drawing depicts a typical event-driven system. And if I'm going to say it very simply, then it's a bunch of processes, producing a bunch of events and consuming a bunch of events, locally as well across boundaries. Some of these events can be also persisted and replayed and so forth. So this is a typical simple drawing of what event-driven architecture or a system that is event-driven could look like. This is by no means anything new. All the way back in 2001, probably dates even before that, but in 2001, 3 guys from California, from Berkeley University in California, they published a white paper called Staged Event-Driven Architecture, where they proposed an architecture to build high-performance internet services, which were very good to condition themselves to the load imposed in a way so they don't overcommit. So, and that have been sold in the stages where the stages have been controlled by the events. So it's a very interesting thing. 2010, Matt Walsh publishes also another paper. Actually, it's more like a blog as a retrospective on his PhD with the SEDA. So for those interested in digging into these matters, there are some good points. What was good about SEDA, what was not good. So I'm not sure, but I think J Storm is built upon this thesis. So the next thing that I want to point out, it's not a software, it's not an architectural pattern, it is a paradigm. Although initially anticipated as an architectural pattern, it's been promoted to a paradigm due to the complexity. So there is lots of things. It's not just building the software, but it's also how you do it, how you communicate. It has lots of things attached to it, and as such, it's also understandable that it's often very difficult to grasp it. I read someplace somebody written, can't remember the name, I'm sorry, but I'm quoting an anonymous person now, but, and it was a woman. She said, as if event-driven architecture was destined to be understood only by few people. And I think we are moving now into the era where it should be actually easier to take that in. The third point is it's not message-driven architecture, it's built on top of it. As such, it's promoting production, detection and consumption of events, where events are simply immutable facts. They are just the source of truth that something has happened. It's not going to happen, it's not commanding, it's more like something has occurred. It's an important state change in a business that we are capturing here. So as such, a typical event-driven system is being built around event creators or emitters. They have different names, publishers as well, but then on the other side they are event consumers as well as channels. So event creators, they don't know who is on the receiving end, so they simply publish the event and they don't care who is consuming, nor they care if it is at all consumed. While the event consumers have the responsibility to subscribe to these events and to react to them. So at the end of that pipeline, there are event channels, which are simply responsible for transmitting events from the producer to the consumer. So maybe before I jump to the next one, there are also other things. This is very core. There are other things. There are syncs. You can put them between the consumer and the transmitter in a way, so you can apply some logic to event streams before the consumer gets it, such as ordering maybe the events, filtering them out, enriching them, or so and so on. So basically, the event-driven architecture has also other elements, but this is again not about event-driven architecture itself. We are talking about why it can be useful to us. What's interesting here is that it promotes something called event-first thinking. This is something that I'm going to touch more on in following slides. As well as it supports various processing styles. We have event stream processing, complex event processing, online event processing. So it begins to paint the picture, the complexity that is lying behind the event-driven architecture. There is lots of ways you can do the things. So the challenge is always to find the right way for the problem that you are sitting with. And just to get a little idea of some of the techniques that we use normally in the event-driven architecture to solve some problems, we're going to touch on some patterns that are available, often used. So we have one that is called notification pattern. In notification pattern we have service 1, which is the producer. It pops the event on the backbone. On the other side, we have service 2, which subscribes to it. But then we have a funny communication between these two. This line here represents that the service 2, the subscriber, simply needs to query the state of the publisher, because the event doesn't carry the state. So event carries only reference data, whatever, order ID, customer ID, and so on, plus what event occurred. But then you need to call the publisher to get the state, if the service needs it. Every pattern has pros and cons. I'm not going to go too deep into that, but I can say that a notification pattern is very good because the events are portable, easier maintainable throughout the time as your event schemas evolve. They are very slim and thin, so it gives some lightweight management of your orchestration of your events. On the other hand, it increases the coupling of your system. So you win some, you lose some. The next pattern is event carried state transfer. Now we can see on the picture is the same as notification, apart from the line in between service 1 and 2. This is simply because now the event carries the state. So to solve the problem of the notification pattern, we move the state in the body of the event, publish it, and then when the subscriber picks it up, it has all the information, doesn't need to talk to the service 1. Now that's good, because now we are virtually decoupled. Service 1, service 2, they don't know about each other. They can evolve independently. But on the other hand, now the event body has grew complex. So you could imagine if multiple services are also subscribing to it, whether they have different demands, how to interpret the state and so on. So that can impose some challenges. What about also if state changes right after the first event has been published, then the subscriber needs to have some kind of ordering mechanism for it not to process the wrong state at the wrong time, and so forth. So also that pattern is good in some cases, maybe if data is mutable after the event is fired, but on the other hand, it can hurt if you place it the wrong solution. So the next pattern that I want to mention is sagas. Transaction that span across multiple services. That's what Saga serves for. On this little picture, we are depicting a orchestrator-based Saga. So there is one big brother that keeps an eye on services, that they behave and do what it needs to do. But there is also choreography-based Saga, which is more native to event-driven architecture, where the whole transaction is choreographed around the events across the services. So services, they simply subscribe to the events that they are interested in the choreography. When that occurs, they then do their own job, and then they publish the event saying, I've done my job, and then the other services that are interested in that can pick it up. So in that way, you can actually get quite complex workflows run in a synchronous event-driven way. So that's also one of the interesting patterns that you can end up using if in certain scenarios. Of course, when we talk event-driven, event sourcing is also one of the almost core patterns, not often applied due to mental leap that it requires when you use it. What it does, basically you store the events. And if you remember from the previous slide, the event is a fact that the state has changed. So that effectively means that you are storing the state changes into a certain database, and that way you can deduce the state of the whole system by replying these events. You can do some cool stuff with that. You can go back and forth in time, and you can alter the state of the system and so forth. But on the other side, you have to remember that you're storing events throughout the time while you're developing your services. But when you want to replay the events from starting from the last year, and you've been releasing your services throughout the year, you have to make sure that they can interpret the old events as well. So again, important to use it there where it makes sense, not just to use it because it's cool and it gives you some potential. And then we move on to CQRS. It's not a native citizen of event-driven architecture, but it's quite often used in conjunction with it, where often the event backbone, the middleware, the messaging middleware, is used as a projection engine. So we have on the left side we have a write model. It just publishes the events when the data changes due to the write operations, and then the read model consumes these events and updates the views. So again, it's a very powerful pattern if you require some flexibility in scaling, where you want to scale your writes separate from your reads and so forth. But again, comes at the cost of some additional complexity. So it's important to keep that in mind when you are choosing what kind of pattern you're using for which solution. And at last, clustered context, which is nothing else but if you have a complex domain, or if you have many domains that are complex, then you don't want to end up with having these patterns just scattered around. You want to cluster them, so you want to group them into the domain. If it is something about order, maybe you're going to create an order cluster. In the complex domain, you're going to maybe link them to a bounded context, so that actually inside the context, the services, they can just do whatever they want. On this picture, we can see that service 1 and 2, they are using the event carried state pattern, while service 3 and 4, they use regular synchronous request during communication. The point is here, when you leave your cluster, then you communicate strictly event-driven. So that's the only difference. But else you can combine any patterns in there. So that concludes the event-driven part about what event-driven architecture is, which different practices we have and how we can apply them. So before moving into the bridging the sourcing silos, you may fire any questions so far. You can comment also on the actual subject of event-driven architecture. Cool. Super. Then I will take on the next line, which is bridging sourcing silos through event-first thinking. Now, the best way, I believe, to depict that is by trying to show how sourcing silos can emerge through application of the command-driven development. And for that reason, I will use one of the clients that I've been working for. That's a company that was building CAD/CAM solutions that were deployed on customer sites on their desktops, and this circle represents their business boundaries. So what happened back in time when they started? They had simply development department, a bunch of nerds just hitting the keyboard as many times as they could. Many times they also hit good keys, and they produced some good software. And then they just shipped it to customers, customer site. They installed it on their desktop, used the software. Very simple, few customers, few developers. But as the customer base started to grow, they started to get feedback that some customers want one thing, other customers want another thing. We all know how irritating they can be. so they needed to evolve, right? So what happened is that they realized that now they need to split their product into modules that the customers can purchase licenses for. And then that resulted in a need of having also a product configuration unit in the organization, so that can actually package these products for the customers based on their purchase licenses, and all that had to be synchronized with the development and releases and delivered to the customer at the end of the day, or a month, or whenever they were finished with the releases. And we can already see a little bit of the notion, the idea of how the communication gets complex, because this is not only system integrations, this is also team collaboration, this is like dialogues to get people to work together across these boundaries. It starts to grow in complexity. But they are still cool. It's not too complex until now the business gets kind of greedy. If you could say, business often does that because they have to. They have to go for the money so we can get paid to do some cool things. So they say we don't want to sell to customers alone, but we also want to sell to partners. So partners can sell to their customer base. But we also want to power all these sales with dedicated resources that are doing the sales. And not just that, I mean, they recognize that CAD/CAM solutions have a very tight relationship with the hardware in regards to customer experience. So they thought, like, you know, why don't we just offer also bundles to our customers so they can buy the software with hardware, and therewith we can guarantee a good experience. And then you need stock as well, because when you have hardware, then you have to ship things, right? And it just gets funnier and funnier, because then they say, oh, we have to compete on the market. So we want marketing involved so they can promote products and do the things. And then, of course, then you need a unique identity across for your customers across all these silos. And we can see where this leads to with all these lines, but what's important to say is that this is not the entire truth, because you see the truth when you lift the legs of one of these, because beneath that there are systems that each department is owning in one way or the other. So what you can see is there is in sales there is an e-commerce solution which is custom made for a website where customers can go in and shop licenses and do the things. There is also Axapta, which is used for order management, license and subscription in a license domain, configuration and product download in a product, and so forth. Here have we TeamCity, Git, we have backlogging, Jira. So basically each of these is hiding a series of systems. So as a matter of fact, these lines are not like licensed to development, but it's subscription to perhaps SimCity hooked on to the build pipeline. Then you have a backlog to a license or a configuration to the backlog, and Axapta to the configuration. I mean, it just explodes. And so it's not anymore, hey, somebody from product, let's integrate with sales. No, it's who from product knows configuration that can integrate with sales, with Axapta, and who in the team city, and what are you doing now? How can we coordinate that? How can we set a meeting in order to extend our business portfolio and functionality? So it becomes very expensive, the team collaboration. So if we go to event-driven, then we just remove all that. We are left with a boundary with a clustered context. And what we then do, we introduce a new inner boundary, which is called enterprise events. Now, enterprise events is just like a bucket for important business state changes. So you just say whatever it's important for the whole enterprise in terms of state changes belongs to enterprise events. But we don't want a bucket like my bucket where everything is just unsorted. We want it more like, Danish style, where you put vegetables with the green with the green and stuff like that. So what you do, you add these topics, which are subscriptions, shipments, products, deployments, and so forth. So each of these topics, of course, can have different events like subscription created or cancelled, or payment made, or commission in regards to partners because they are selling stuff to our customers. We need to reconcile with them as well. So you put simply you organize the enterprise events into some smaller buckets, categories if you want, called topics. That makes sense. And once you have done that, then what you do, then you just open up for clusters. You can do this one at a time. I'm putting them all at once. But you can say the show goes as it used to, but then we are enabling our development to join into this enterprise. Then we do with the product and so forth. So you plan the transition so that actually at the end of the day, or rather said maybe at the end of the year, or maybe after 2 years, then you actually have them all joining this enterprise event cluster, where actually they are publishing and subscribing, right? So what's interesting here is that all of a sudden from this previous picture, now the events get pushed forward. Now we are not talking Axapta to some other system. We are not talking sourcing silos anymore. Now we are talking subscriptions. We are talking deployments. We are talking business terms which are really easy to grasp by everybody, or non-technical people. I mean, you get a more business common language when you are discussing the integration across all these silos. So that's why by doing the event first thinking, by pushing the events forward, by making them a first-class citizens in the integration dialogues, can actually simply remove the complexities. So simply wrapped up, facts before actors, easier to grasp for non-technical people, no peer-to-peer dialogues, no complex team collaboration. That's one of the obvious things. The funny thing that emerges out of this, that is often hidden and very hard to recognize, is actually that the domains now can evolve independently. And this is a little funny drawing I took from internet. Google has lots of cool stuff. You can always get it on. So this is our old chicken egg paradox. The funny thing is, in a command-driven world, it is a paradox, because chicken cannot command egg anything at all before egg is there. Neither chicken can be there before the egg. But in the event-driven world, I mean, we are almost like going into a quanta world where the events, they can occur without any preset order. So in that way, they can both chicken and egg, let's say sales and development, they can evolve independently, because now the teams, they are not talking about how can I command another system to do something. Now they're just talking, when I have done something, I just put it out there, and then the other systems can do whatever they want with it, which means that we are isolating the teams around business capability vertical rather than mingling across the technical capabilities, which is for me kind of a horizontal, but maybe because I'm from Serbia, I don't know, could be also vertical. Okay, so that's event first thinking. I'm not going to put more words on it, so it basically means decouple on a team level. So get your teams together so they don't depend too much across each other, and that you can achieve by pushing the events forward and talk about that. But that's not enough. We also need to, because this is all still the methodology, this is not even a methodology, this is actually a praxis. So it's not even like a method of doing something, it's just something you practice. But you can't do that if your system doesn't support it, if the architecture of your system is not supporting it. So what you need to improve the cohesion of your system so that your components are decoupled or at least coupled on the system level in order to be able to be so flexible. So, and I believe inversion of responsibility, which I'm going to explain in a moment, which comes from event-driven architectures, exactly provides us with that. And as well as with the previous, with the event-first thinking, I will hit. If somebody likes command-driven, you can just come and slap me afterwards, but I'm going to go after it in this presentation. So again, I'm going to use now a license again from this company, and we're going to present one command-driven, and then we're going to look at it from event-driven perspective and see what has changed in that picture, right? So we have 4 domains: sales, customer, license, and product. And then we have a customer. I don't know if this is an angry or a happy customer, but it is nevertheless customer who wants to shop new license through the e-commerce solution, which is in the sales domain. Now this e-commerce solution sets the order in Axapta. When this order is confirmed and everything is okay, then it calls the order service in the license domain, instructing it to update the license for this customer. So then this order service calls the license service in its own domain and says, okay, you have to update this customer bought a new license, so you have to reconfigure the license at the subscription, right? And when that is done, then the order service calls the configuration service, saying you need to update now the configuration of the product, because this is a license for the module where there is other set of modules that the customer has bought. So you need to update the configuration to include this new thing. Here there is some complexity because they have to be compatible. So now this configuration service needs to calculate the new baseline of all the modules that customer has purchased that are compatible on one desktop. Once that is done, then it just goes to download service and says, make it available for a customer, while CAD/CAM desktop on the customer's site pulls the configuration once in a while, and once this configuration is created, the new one since last, then you can start downloading the files and it updates the system. So beautiful. But the problem is that we have mingling of responsibilities. Number 1, e-com to order service with the update license. Number 2, update configuration between order service and configuration service. What does that mean? Besides that, it definitely means increased coupling that we can easily agree on, but it also means that anytime you want to change something to the shop license, you need to take in consideration 3 teams and coordinate them, talk with them, because if any contract changes anywhere, if flow has to change, if new steps have to occur for whatever reason, the teams are not decoupled. They are still tightly coupled because the components that they are developing are forcing them into it. So this is again one demonstration of how being agile on the business level, if you don't go agile on architectural level, you simply force your organization to be rigid and perform some rather expensive management practices to get things to run. And And in the best case, the things run. In the worst case, the things can go and be a little more complicated, and then it just goes too slow. So if you look at the same example from event-driven, we have sales, customer again, license and product. We have the event backbone in between, and this time the customer is still not too happy, but but he would like to shop something through e-commerce. Then the e-commerce says to Axapta, can you just create this order? And then when all their processes are finished, when order is confirmed, then it comes order confirmed event out on the backbone. So at that point, as far as sales are concerned, they are free. So they don't want to think about what happens after. In the license, order service has responsibility to subscribe to that event. It picks it up, it calls license service, and once license service has completed its own job, then we get subscription updated event. And so it continues with the product. Configuration service configures the product for the customer. It updates download service, publishes configuration completed event, and now we can even imagine that the customer's CAD/CAM desktop can pick up that event, so we don't have to pull the information anymore, but we can get it applied. And if we want, we can even extend that. So now the customer CAD/CAM solution can publish the download the files, of course, and then say configuration applied. Now this new event, number 4, we can imagine that it can be used for statistical reasons to see how our customers are adopting our new versions, in which regions and so on, everything real time. And that's not put here anywhere, but I can just say that if you want to go real time, if you want to have a real time situational awareness, that I'm afraid of, you don't really have much option, but event-driven. It's very tightly bound together. So if you're going to sum up the event-driven shop license, then we can end up with saying that it moves control to receivers. While in command-driven, it's the service that is orchestrating the flow that has a responsibility to command other services to do something. Here, it doesn't care. It's actually the service that is receiving, like order service and so forth, that has a responsibility to react to it, which effectively means that each service now owns its flow. So there is no coupling between any of these services with any other services in other domains. So the flow is totally isolated now on the domain level, which means the team that is developing it, as long as they understand the event and they are subscribed to it, they can freely evolve on their own without having to have any dependency to sales or anything. The only dependency that can occur is on the event level. So if you introduce new events, if you change something in the event with the compatibility issues and so forth, but else it's perfectly isolated. So that effectively means that the services are decoupled, and if you're gonna sum up the inversion of responsibility in simple words, it means low coupling, high cohesion, and that's a cool thing. I mean, whatever you build, when you build software, you will try to attain this. This comes naturally from event-driven architecture. It simply forces you in that direction. You can't do otherwise. So I don't know how much time we have left.
10 minutter.
10 minutter, cool. Then I'm going to speed up. Embrace changes through evolutionary architecture. So what's interesting here, we take shop license example. I just want to say before I continue, there is a book called Evolutionary Architecture, published by O'Reilly, 2018, I think. Look it up, very interesting points. Lots of these things that I'm also presenting here is inspired by these guys. So what we have here is we have the same example, but the business say now there are some regions that are performing poorly with some products, modules, so we would like to do something about it, and they say, the business executives say it's a marketing department that wants to do. And now you think, okay, what do we do now? Now marketing, there comes a whole new domain with a set of systems and everything into the picture. What do they do? But they say, like, you know, we run event first thinking. We think that the order confirmed event is our entry point. So we're going to build something that listens to it. So all of a sudden we get a marketing included. They pick up the order confirmed event. They run the, they call the promotion service, which they want it to be AI, so that it can automatically promote some products that are needed, that are performing poorly in some regions. And what's interesting here is that they can, once that happens, they can publish product promoted event, which you can even imagine goes back to sales, where they can maybe adjust prices and make some promotional prices to make things attractive. We can even imagine that they can promote trials where this event can be also picked up directly by the configuration. They can configure a customer's product so that when they download next time, they get little extra stuff for 3 weeks or 3 months or whatever, so they can get a little attracted. All this without tipping over anything. We just introduced the whole department with their whole technology stack, which just hooked on to existing event. But that's when the business extends. We have also another thing, which is what about hypothesis driven development? So we have an idea that something is cool, such as our configuration service, which runs some complex algorithms to figure out the compatibility between the modules and stuff like that. It's operating on a relational database. It's heavy when we get too much load through and so on, but we saw this graph database that sort of shows us that we can build a compatibility tree between modules, but we are not sure about it. So what we do with the event-driven architecture, we say it's also called mirroring pattern. We say, okay, but then let's just put directly in production configuration service version 2, where the whole technology is changed. So now you have one running, let's say, on a SQL server, while the other one is now running on a graph server database. And then maybe the sharp eye says, but what about this configuration completed event? So because if this one does exactly the same as this one, then they both fire the events. And yes, they do. The only thing is that the first one fires version 1, the new one fires version 2, and our customer desktop still consumes only version 1. So here we can actually prove or disprove our hypothesis already at this level in production, on production data, without impacting anything. Very isolated development. We can also imagine when we are happy with that, we can release some to a limited number of customers, a version that can actually work on a version 2 configuration available. And when we are happy with that result, then we can say we can take the old one out. So this was step by step proving our hypothesis in production. There is no like a long discussions and 3 months or half a year building something, put it, and then you hope it works. Here we just go straight in and we put things in and we try them out in the production environment, see how it works, and we just phase them out. So the another thing is that even this version 2 event can be picked up again here to prove our hypothesis, to see how the adoption of this new way of working is operating, so before we kill the last service and so forth. So just like a one step at a time. And if we're going to sum up the evolutionary architecture, it basically means design for change. So the change is inevitable. We shouldn't argue about it. We know it's going to change, whether it's going to be business needs, the strategies, or it's going to be technology. So we don't need to get stuck with our architecture, with the old technology stack, if there are some new cool opportunities, as well as we don't really want to say to a CEO, well, I mean, it'll take a year to do this, or it's going to be too expensive, or it's going to be too difficult. So we want to embrace the change. We want to say, just throw it at us. The stuff that we have, that we are working with, can quickly adapt to it. The second thing, neutralize Conway's law. I don't know how many of you know it. I think this is it's just a statement saying that the companies or organizations that build systems, they are forced to build systems that reflect their communicational structure, and that's also quite true. That also represents how architecture and the organization is tightly coupled together. But as we could demonstrate with our extension of the shop license, where we included a whole new department, so that means the organizational structure and communication has changed drastically. in-shop license picture, the architecture, we could actually embrace that change and quickly adapt to it, and that way we neutralized the Conway law, which also comes naturally from event-driven architectures, which is interesting part of it. So I assume 5 minutes left?
Yes.
5 minutes for the for the last one. I could do this one in 10 seconds if I say, well, it's just the previous 3 things. So, so I say event first thinking, inversion of responsibility, evolutionary architecture, and we are agile on architecture level. But that's not true. So there is more to it. So let's look at that part. The way I like to explain that is in 3 steps. The first one is when we look at the evolution of the architectures. In this case, this is microservices. We started with monoliths a long time ago, super cool, but then we realized that they should talk together if you're going to make sense out of it. We cannot just like build monoliths all over the place that do the same thing all over the place. So we use the RPC to integrate them. We know what that led to, something difficult to maintain, and then we moved into something that we hope will solve the problem, the enterprise application integration, which resulted in huge monolith integrators, if you want, often also quite expensive middleware. Then we say, let's go back to splitting the things, but contractually. So we moved into a service-oriented architecture with a SOAP standard. Then continuous delivery and Docker and so on. The technology suddenly takes a rapid change. So we say, what about these microservices? Let's do them. But we didn't stop there. Where we are today is actually event-driven microservices. So that's the next step in the architecture. The point here is that that was a natural step. All the integrations were fine if you had 5 or 10 or 20 services integrating. But when you talk microservices, we are talking like hundreds on a very mature setup on the big enterprise. So if you want to do request-driven or command-driven on that level, then it's going to be very complicated. So people already started to move into that direction. Like we need event-driven microservices where you can see different patterns can apply how different microservices integrate through event-driven architecture as well as how you are clustering them. But that's not enough. This is just in the architecture. We also have emergence of the standards. Cloud events, which is from Cloud Native Foundation, the working group. It was cloud events, but it's moved now into the serverless working group. I think now they are at version 2. Lots of cloud vendors are already sort of jumping on it. The mission is just to standardize the event declaration and production across, I can't remember exactly, but basically they say across everything and beyond. So they go like IO devices, public clouds, private clouds, serverless functions. So there is a really strong initiative to encompass this cloud event standard into the serverless infrastructure. Also worth looking into. And finally, maybe my favorite, I don't know, I just love this because, at the end of the day, you end up working with some cool software and tools, So who doesn't want to, do a little bit, well, I'm saying who doesn't want? I didn't want for some time ago, but I recommend everybody to give it a chance. It's really lots of fun working with this cool software like Kafka and Samza and Event Hub and Event Grid and Apache Storm and so on. This is all really powerful event stream processing machines that can really get you to do some cool stuff rather quickly at a cost of complexity and a learning curve, no doubt about it. But what I believe, when you put up these things together, my strong belief is that can attract talents. And that's what you need. I mean, you as an organization, you need to get talents onboarding, because if you have the previous things that we spoke about, and if you also get the talents onboarding, then I truly believe you can become agile on architecture level. There you go.
Perfect. Det var alt sammen skide godt, Milos.
Tak.
Men
det skal der altså være.
Fra mand hernede og kan ikke komme ud af sin RPC-sump. Gå tilbage til den der produktsalgs-ting, hvor I gør det. Ja.
Er det her?
Ja, det kunne godt være den. Fordi nu vil jeg gerne være djævelens advokat, fordi det der passer skide godt til forretninger, der tænker i asynkrone forretningsprocesser. Kan du ikke skitsere, hvad sker der, hvis salgsafdelingen finder ud af, at vi må sgu ikke sælge ting til folk, som vi ikke kan levere. Så nu har vi altså brug for, at vi kører ikke salget igennem over for kunden, før produktkonfiguration, eller på en produktkonfiguration, som ikke passer. Mm-hmm. Hvordan rammer det krav den arkitektur?
Mm-hmm. Jeg skifter nu til dansk. Jeg kan også dansk. Jeg har boet her i Danmark i lang tid, så selv min engelsk har dansk accent. Der er mange forskellige mønstre, ikke? Så igen, hvis det situation kommer, så kan det være en notification pattern, der er inkluderet, hvor så configuration service skal query staten ind i salen. Du skal igen kan sige, at det er stadigvæk product, som ejer workflowet, fordi der kommer stadigvæk event igennem, men denne gang configuration service skal sige, hvad skal jeg gøre med den her? Altså hvad er staten host? Så det kobler subscriber til publisher, gør den mere, hvad kan man sige, arkitekturen lidt mere rigid, men team, som udvikler produkt stadigvæk er helt isoleret fra udviklingen med sales på den måde. Og så kan man omvendt sige, hvis det her er immutable data, så kan vi også sige fint, send state, altså med event carried state. Så på den måde, the configuration service kan få også information, der fortæller den, at nu skal den gøre noget særligt, ikke? Så den tolker på den måde, ikke? Så det er...
Okay. Tak.
Det der er et klassisk spørgsmål fra nogen, der er vant til at køre command.
Jeg gemmer mig lige lidt.
Det man skal indse, det er, at alle de her events, de taler i datid, at kunden har bedt om at få et produkt. Og så er det klart, at han er måske ikke glad for, at han har fået produktet. Men så kan man stadigvæk give kunden et svar tilbage, hvor man siger, ja, vi har modtaget din besked om, du gerne vil have den. Der går måske et par dage før, at du får endelig besked på, om vi har verificeret, at den er på lager. Ja. Men så giver man øjeblikkelig besked på, at det er sådan, at situationen er, og man taler igen i datid. Så man står ikke og staller nogen steder, man sender events ud hele tiden i en lindstrøm om noget, der er sket. Og så skal man erkende, at det er okay, at kunden ikke bliver glad lige i samme sekund. Så man skal ikke lave active wait nogen steder i sådan et system her. Det er meget vigtigt, at man alle de steder, hvor man kobler ind i eventsystemet, at der er man ligesom i ro. Der er det en gemt state, og det er okay. Der er ikke, man står ikke og venter på at få svar nogen steder fra.
Altså, ja, altså, der er så cap theorem, ikke? Altså her kommer det på bekostning af consistency. Så der skal man lige acceptere, at på et tidspunkt data bliver konsistent på tværs af landskabet, ikke? Igen, jeg vil lige påpege, at det var ikke så meget om eventdrevet arkitektur, men vi kan sige, at de udfordringer med den er nemlig at kunne tracke eventflow på tværs af det her. Der findes måder at gøre det på. Vi har rigtig stærke værktøjer for correlation og monitoring osv., hvor man kan lynhurtigt få stykket hele billedet af, hvad der foregår. Men under alle omstændigheder, event skal stale, det kan gå på dead letters osv., så der er nogle håndteringer, som man bliver nødt til at acceptere, at når jeg klikker på noget som lidt i command-drevet eller request-drevet arkitektur eller designs, så kan der gå noget tid, inden det faktisk bliver reflekteret i en sand billede. Men det ændrer ikke på faktum, at vi har reageret på noget, som vi kan garantere er sket, og som er immutable. Så på den måde, vi kan tillade, at vi fejler. Det kan være grunden til, at der er bug i servicen. Vi kan fixe servicen, vi kan putte den tilbage i tid, og så kan vi bare resume. Så der er sådan en del andre teknikker, som man skal bruge, når man forholder sig til den slags ting. Ikke? Så, men det er udfordrende, det er på ingen måde, jeg vil gerne sige, alle kan gøre det bare, men det er også håndterbart, kan man sige.
Jeg så Lars havde et spørgsmål, er det en hurtig en? Jeg har også et.
Måske.
Meget lang tid, så.
Og jeg har selvfølgelig lyst til at spørge om test, fordi i forhold til command-driven architecture, er der særlige udfordringer, når man skal teste sådan et event-drevet system, eller er der gode patterns også på testsiden? Ja,
det kan man sige på den her måde. End-to-end test, hvis du gerne vil have end-to-end test for, lad os sige, shopping license example, der siger order confirmed, product promoted, configuration complete, subscription updated, og så tjekker du ind i CAD-CAM, er den der? Er det virkelig sådan? Så bliver det udfordret. Fordi det indfører den kompleksitet, at det hele kører asynkron. Jeg nåede ikke at se, jeg vil ikke forstyrre det, men jeg har været i en BIX, hvor deres end-to-end test på eventdrevet arkitektur, hvor de har forsøgt det her, begynder at køre over 24 timer, så de kørte kun en gang på døgn. Men desværre så begynder det at overlappe med det næste kørsel. Så det er udfordring. Men på den anden side, i det man vil gerne have domæner og evaluere uafhængigt af hinanden, så kan man sige, at vi er lige glade for hele stærk, fordi teams skal være afhængige af hinanden. De kører deres end-to-end test mellem Accept og Ecom og så videre, hvor man kan anvende blandt andet de principper, som du har vist, ikke? Hvor så har vi kun event backbone og verificering af, at services kan modtage og processe event af et bestemt version. Så det betyder, når det kommer til integrationstest, så er det faktisk, kan min order service nu processe event nummer 1, version 1. Og den ligger så der, hvor ansvar ligger, fordi vi har flippet nu ansvar til receiver, så det er dem, der laver en såkaldt integrationstest, som betyder, at nu kommer event ind, hvad sker der af den version. Og det er der, hvor så eventkommunikation skal foregå på tværs af BIX'en. Når vi ændrer på en enterprise event, så skal det kommunikeres, sådan at man eventuelt dem, der vil gerne abonnere på de nye events, skal opdatere deres test suite. Der er også noget ikke-orkestrering governance omkring det, fordi i større BIX med rigtig mange systemer, der kan komme rigtig mange topics, rigtig mange events, der går ind og ud, og folk subscriber, så man skal også have en måde at kommunikere på, hvad der er aktuelt, hvad der ikke er aktuelt, hvad kan du bruge, hvad du bruger ikke. Så der er absolut nogle ting, som skal på plads, for at en enterprise kan håndtere det her mest optimalt. Ikke? Yes.
Jeg sidder og tænker lidt i retning af tanken om, at gennem forskellige designs, så flytter man kompleksiteten. Og her der tænker jeg, at altså, er der ikke, eller hvad sker der med kompleksiteten af indholdet i de events, der bliver skudt rundt? Eksempel, altså en tilstand, som bliver givet fra en event og konsumeret af en anden, det er jo som et funktionskald af en eller anden art, ikke? Der man reagerer på, hvad der er nede i den der, og det er jo en hård binding mellem sådan to services. Og hvis du har den hårde binding på tværs af 3-4 af de der stiplede linjer, eller stiplede kugler, jamen så har du så i virkeligheden ikke bare flyttet men i virkeligheden i hvert fald noget af din kompleksitet, flyttet den ind i det designet af de events. Og, altså.
Ja, det kan man sagtens sige, hvis man tilegner ejerskab, lad os sige, order confirmed til et bestemt system. Så kan man sige, på en implicit måde bliver det kommanddrevet, fordi så har Acceptor ligesom kommanderet til verden, at de skal gøre noget. Men pointen er så igen, at ansvar for at modtage de her events og behandle dem, ligger hos modtageren. Og hver modtager, vi snakker om fleksible skemaer. Vi snakker om, at man deserialiserer bare med kun de her ting, som order service har brug for, mens configuration service deserialiserer det, de har brug for. Så det er en helt fleksibel måde at integrere det meget, hvor man siger tynd snitflade, som man integrerer på baggrund af. Så det er ikke en kontrakt, hvor man siger, at den her event har den her struktur, og alle skal kunne deserialisere det her kontrakt, når det skal modtage den. Nej, det kan være, at order service skal have bare order ID og kun ID. Derfor er deres deserialisering foregår fra den her JSON kun til den objekt. Og hvis der bliver kompatibilitetsissues, så kommer der en ny version, og så kan andre services at will introducere håndtering af den nye event. Så på den måde, det stadigvæk giver noget fleksibilitet, men under andre omstændigheder har også den kompleksitet, som du snakker om, fordi når du integrerer på tværs af systemer med data, om der ligger i en event eller i en kald, så skal du håndtere det, ikke? Det er jeg enig i. Men det er bare, at man skal vende det om. Man skal ikke tænke mere system til systemer eller til system. Nu skal vi snakke bare om order confirmed event. Hvad er der i den? Er det en transportable event, som er tynd, eller er det en kompleks, og hvordan vi versionerer den? Og der er så en helt anden topic, som vi kan også snakke om, hvordan man versionerer events, hvordan man ligesom sørger for, at al den her kompleksitet af asynkron kommunikation, der er i den potentie også, der er meget vigtig. Vi har her også 2 services, der kalder download service, fordi events, de er ikke så smukke som i vores request-drevet, hvor man kan sige only once. I event-drevet systemen, det er at least once delivery. Det betyder, at du kan få samme event flere gange, og det skal modtagerne kunne håndtere også, og så videre. Og der er teknikker for det også selvfølgelig. Det er ikke noget nyt, som sagt i starten. Det er gammelt forsøg på at gøre sådan noget, som vi har så lært undervejs og bygget noget cool software og tooling omkring det, ikke? Så, men absolut med udfordringer.
Jamen, der var lige Martin, den sidste. Vi
Du kan lige bare tage det.
får den lige her.
Okay. Er det for nemt at sige, at det er en asynkron servicebus?
Jeg vil sige, at man kan bruge service bus, fordi det er bygget om på message-driven architecture. Fordi den bruger nogle elementer af det, og det er nemlig message queuing, ikke? Eller heller sagt advanced message queuing protocol. Så på den måde, jo, det kan man sige. Men der, hvor det bliver så væsentligt forskelligt, at du kommunikerer ikke noget andet end en faktor, at noget er sket. Så der kan man sige, at den væsentlige forskel ligger i. Ja, så du bruger samme middleware, messaging-oriented middleware, men du bruger det til at sige, jeg gjorde det, eller det her er sket. I stedet for, gider du lige at gøre det her. Så det ikke er asynkron kommando på nogen måde.
Et real life eksempel, det er jo for eksempel Instagram. Jeg så sådan her ud på det her tidspunkt. Fluff. Så må folk kigge på det, hvis de har lyst.
Ja. Super.
Mange tak, Milos.
Ja, det var så lidt. Okay, tak.